Good morning, ladies and gents. Mr. Lesham is here, and we're moving on. We finished with parabolas or quadratic functions, and we're moving to hyperbolas. Let me start by reminding you that the mother graph for hyperbola is y equal 1 over x. And that was quite peculiar and a different kind of function that you didn't come across before. The weird thing about that, it had two parts, like two bits in it. Okay, remember that one? And the other thing which was strange about it is that it had asymptotes. The first time we got this concept of asymptotes. We have two asymptotes here, a vertical and horizontal. And the thing about asymptotes, what is an asymptote really? What is an asymptote?
Line of symmetry.
It's not line of symmetry. Line of symmetry is something else. It's lines that the graph gets closer and closer and closer and closer, but never really reach. Okay? So these lines can carry on, and they get closer and closer to these asymptotes, but never really reach. Often, like any other lines, like any other graphs, these lines can be given a name as a function. And the horizontal asymptote is y equals 0, because everywhere here y is equal 0. Yeah? Vertical asymptote is obviously x equals 0. Okay? Now, what we say here, we say that this hyperbola is not defined at x equals 0. It's not defined at x equals 0. And I've been brushing this for the last couple of years and I haven't really addressed it. And now I'm going to try and address it. What does it mean that it's not defined? Why is y equal 1 over x not defined at x equals 0? Let me hear what you've got to say. There's two possible answers you can give me. The first one, which you didn't give me, but it's the easier one, is that if I put x equals 0, then I have to say 1 over 0. And we know from I don't know what grade that is undefined, right? But again, that doesn't really explain why is it undefined. You're just being told it's undefined. Okay? So Guzwe gave me some good answer here. Okay? As I get closer and closer to 0, okay, my answer, my y's become larger and larger and larger. I can't put a number. You put a huge number, trillion, okay? It's bigger than that because it still goes up and up. But actually the answer is even more complicated because it's not just bigger than any number, it could be all at the same time smaller than any number. You understand what I'm saying? When I say I'm getting close to x equals 0, it depends which side you're coming. If you're coming from the positive side, yes, it's going to be bigger than any positive number. In other words, it approaches infinity. If I come from a negative number, like minus 0,0001, actually I'm going down to a minus infinity. So it's completely undefined. It's somewhere between highest number in the world and the smallest number in the world. It's undefined. Okay? We've got a problem here. Okay? I'll pause. So now we need to generalize this mother function into this. This is the form that we're going to do. I'm hoping you can see it. Y equal ax plus p plus q. Okay? Last year, by the way, I'll write it in blue. We had something similar, but we didn't have the p. We had y equal ax plus q. Okay? So maybe let's start with the a and q. Let's try and understand what the a and the q do. Okay? The a, like in all these families, it stretches it. So if I make a larger a, then it's going to just go like this. I'm going to stretch it. But that's only if a is positive. What happens if a is negative? It flips things around. Like the same thing in parabolas, and the same thing will be in exponent. So for a negative a, I'm going to draw a negative a, we're basically reversing it. It goes like this. Okay? So a, if I have, let's write it down like this. If a is positive, what I'm going to get is a graph that looks like this. I don't know if you can see it there. Yeah. Okay? If a is negative, that's 8, but larger than 0. If a is smaller than 0, these guys get flipped. Okay? Right. What about q? What does the q do?
Vertical shift.
Vertical shift. Okay? Because we're adding a number. If I'm adding, I'm going to get rid of this one now. Okay? If I'm adding, let's do another function. Okay? I'm going to keep this one. Okay, I'll draw another one. Sorry. This is y equal 1 over x. If I shift it now to, let's say, y equal 1 over x plus 2, basically I'm moving everything up by 2. And the way to draw it, okay, as I told you before, is always start with the asymptote. If you have a graph with asymptote, okay, it's not just hyperbolas have asymptote, also exponent, okay, always start with the asymptote. So if I shifted it up, did I change the vertical asymptote? If this moved up, did I change it? No, the line that is like this and it just moves up, it's the same. Did I change the horizontal one? I certainly did. If this moved up by 2, now it's going to be there, yeah? So the new asymptote is going to be here, y equal 2. It crosses here at 2. Okay? And now this, all these dots, I'll draw a dotted line. Okay? This is going to be here, this is going to be there, going to be there, going to be there, going to be there. We're going to have a line that looks like this. Okay? This move up there, this move up there, this move up there. We're going to have a line that goes like this. Okay? Maybe give it a solid line in blue. So we have a new line. Everything moves 2 up. Okay? So that's what the Q does. The Q is vertical shift. Vertical shift. That's what we've done last year. Okay, I'll just pause for question and we'll move on to grade 11. Lastly, guys, okay, we're going to try and find out what the P is. Just a guess, do you know what could be the P? It's the one thing that we haven't mentioned yet. It's a horizontal shift, of course. The P always use horizontal shift. Horizontal shift. Okay? So, in this example, I've drew the mother graph, and now I've changed it to a new one, 1 over x minus 2. Okay? Let's see that this is indeed, you can tell me now, what is the shift? How much am I shifting by? 2 to which direction? To the right. Minus means to the right, plus to the left. It's a horizontal shift. I'll pause here. I'm going to convince you now also why this is, because I can see some of you getting confused, thinking, hang on, sir, isn't that just a shift down? I'll do minus 2. No, I will have minus 2. If I had a minus 2 here, it will be down. But I'm going to convince you why. Because look at this. At which x this is not defined?
2.
At 2. Before here, y is not defined when x is 0, because we don't want to have 0 in denominator. We never want to have 0 in denominator. It's not going to be defined when there's 0 in denominator. But we're not going to have a 0 denominator when x is 0. If I put 0, okay, I'll have 1 over 0 minus 2. That's minus 1 over 2. That's okay. Okay? Just like Finn said, we're going to have a problem at x equal 2. Then we're going to have 1 over 0. So my vertical asymptote moved 2 to the right. My new asymptote is going to be there at 2. Okay? And the new graph is going to be like this. Okay? Okay? It moved to the right. Okay? Generally speaking, this is what you need to remember. This is your formula. This is the one form. If I'm not mistaken, we only have one form for hyperbola. It's only the parabola that had a million forms. Okay? And you just need to remember what these things, okay? That is something that controls how steep it is, and if it's this way or that way. Positive A, it's like that. Negative A, it's like that. This is the vertical shift, and this is horizontal shift. Okay, let's pause here and let's solve one problem together. Okay, guys, so we're going to start our first example, and then we're going to actually learn something else that I left out, line of symmetry. And if we don't do that now, we'll do it in the next lesson. We're giving this function, okay? How do I know it's a hyperbola, by the way?
It's a fraction.
Yeah, whenever there is not just a fraction, but the x at the bottom, when you have x at the bottom, then it's definitely a hyperbola. We know it's a hyperbola, we're going to have a problem when the denominator is 0. So now we're looking at this. Is it going to be orientated this way or that way? Top or the bottom? The bottom one. Why? Because A is negative. But before I even draw that, what do I start with when I sketch? I need, what's that? Asymptotes. I must always have the asymptotes. So I have to figure out what my asymptotes are. Okay? And you know, if I started with a, I'm going to just do it in a dotted line. Okay, if this is my mother graph, okay, and then by timing it by -1, I actually flipped it. So this is really my mother graph. Okay. Now I've shifted it. I shifted a little bit up or down. I shifted up or down. Up. That's the vertical shift. I shifted it right or left?
Right.
Right. Okay. How much did I shift it up? 1. That means my horizontal shift, or horizontal asymptote, is now y equal 1. That was here and now it moved there. Okay? That's my new horizontal asymptote. It's all shifted up. It used to be there, now it went up. Okay? Now, initially the vertical shift was here. That was my old vertical shift when it's just 3 over x. But now I shifted it to the right. How much? 3. So my new line of symmetry is going to be x equal 3. These are my 2 asymptotes. And that's my grid. That's what I base everything on. Are we happy with that? Okay, I'll just pause here and see that you got to. Now, actually, before we move on, I'm going to do something that I didn't talk about, but I will need it in a second. What is this coordinate? There's an x and a y here. What is the x?
Isn't it the 3?
Oh, it's 3.
It's 3. And the y? 1. Okay? Because everywhere here x is equal to 3. Everywhere here y is 1. So at this specific point, that's like the center of the hyperbola is 3, 1. And we will need it a bit later on. Okay? Right, now I need to sketch it. So I've got 2 options. Either option 1, I'm drawing it like this. Option 2, I'm drawing it like this. Option 2, of course, is the right one because as you told me already, A is negative. So my graph, my sketch will be like that. Okay, are we happy with that? Okay, we got the shape marks. Okay, we got the hyperbola, we got the right orientation. We got the asymptote, that's probably worth 3 marks in itself. What am I missing?
Where it goes to the x and y axis.
X and y intercept. Here's an x intercept, here's a y intercept. Start with the easy one, let's get the x intercept, the y intercept. How do I do that? How do I find that?
You do x equals 0.
X equals 0, thank you very much. So f of 0 is -3, 0 minus 3. Put 0 plus 1. That's equal -3 over -3 plus 1. That is, can somebody do it? -3 divided by -3. Ah, yeah, you're right. Oh. Okay? Yeah, that's right. It's 2. Okay? So the coordinate here is 0, 2. Are we happy with that? Yes, everyone? Okay, moving on to slightly more difficult. This is the y-intercept. X-intercept, what is 0? The y is 0. So I substitute f of x is the same as the y. Yeah? So I put 0 equal -3, x minus 3 plus 1. We solved stuff like that, I think, in grade 9, when you have this algebraic equation in the denominator. Okay? All right? How do I solve such a thing? Let me just put that there and see if you can figure it out. Good answer here, Jacques. I'll just change it slightly. What you said is absolutely fine. Personally, I would rather move them 1 to the other side and make it also negative. This is already negative. This is positive. Leave a positive there. If I move him to the other side, I'm going to have 3x minus 3 equal 1. Are we okay with that?
And you multiply by x minus 3.
Next thing, we multiply by x minus 3. But we should do something here. Okay? Don't know if it rings a bell. We should put, I can't remember what you call it, but a restriction. You're going to put a restriction. Remember that from grade 9. X is not equal 3. It's not 0. It's the denominator must be 0. So x is not equal 3. To be honest, it's not going to be an issue here because in these hyperbolas, x is never 3. Because we know it, the formula, the hyperbola is not defined for x equals 3. So you probably don't have to. Okay? Anyway, now, like Jacques said, we're multiplying by x minus 3. We're going to get 3 equals x minus 3.
Move the 3 over.
X equals 6. Okay? So this is 6, 0. Okay? I'll pause here and we'll see if I can carry on. Okay, chaps, I'm going to continue with that in a second. Just a second. Okay, so after we sketch the graph, we need to, in some questions, they might ask you to write down the equation of certain lines. 2 lines we already spoke about that, but I want to just make sure you write it nicely. So the lines are the vertical and the horizontal asymptotes. So in a test, if they ask you to do that, you just write down, okay, I'm just going to erase this. Okay. You're going to have to write vertical asymptote. And we found that the vertical asymptote is x equals 3. Okay, just write it clear for the examiner so you can see it. The horizontal asymptote we saw here is y equals 1. Okay, that was pretty good. As I said before, there are 2 more lines that we need to talk about. And these are the lines of symmetry. Okay, we've touched this now. We did that last year. Okay, and we can see that there are 2 lines of symmetry. What do I mean? If I draw a line through this, what I call the center of this graph, I can draw a line here and another line there, 90 degrees to each other. These 2 lines are lines of symmetry. What is a line of symmetry again? If I fold this graph, imagine this is a whole paper, and I make a fold here and I turn it around, what will happen to this arm of hyperbola? It will just overlap this. That means there's a symmetry. If I put a mirror here, okay, the reflection of this arm will be identical to this. So there's a line of symmetry. Okay? But there are actually 2 lines of symmetry. That is one, and this is the other. If I fold this paper, these 2 arms will just overlap these 2 arms. So there's 2 lines of symmetry. And what we need to do now is find the equation of these lines of symmetry. Okay? Now, there's 2 things you need to know about them. First of all, their gradient. Their gradient, and I'm not proving it for you, but I think hopefully you can kind of, maybe kind of get convinced. But the gradient of this one, okay, this is a straight line. The gradient is obviously positive, but more than that, I can tell you that the gradient is, we use the letter n, plus 1. And the gradient of this one is minus 1. Okay, so let's start with this line of symmetry. Okay? I know that a general line, we haven't done work with lines this year, okay, but we've done it a lot in grade 9 and 10. You still need to know it. The general equation for a line is mx plus n, or ax plus b. What is m? M is your gradient, and n in fact is the y-intercept. Okay, now we know what the m, but we don't know what the n. I don't know where this line crosses the y-axis, but that where the second clue comes in. Okay, if you remember early on in this problem, we established that those 2 lines and what we call the center of this graph goes to the point 3, 1. So if I know that this line is y equal mx, I know what m is. M is 1, so I can write as x plus n. I still don't know what the n is. Now I can just substitute x equals 3, and then I will have to substitute y equal 1. So 1 will be 3 plus n, which gives me n equal minus 2. Okay? And just moving the 3 to the other side, n is minus 2. So if I actually want to write now the lines of symmetry, I'm going to get 2 answers. The first line is this line. Is going to be y mx plus n. I already knew what m is. M is just 1, so it's going to be x plus n. Now I know what n is. N is minus 2. So the first line of symmetry is y equal x minus 2. Now we need to find out the second equation, this one. Okay? Right? Now we have y equal, the n right now is negative 1. So it's not x plus n, It's negative x plus n. Now I can't say n is again minus 2. I mean it might be, but probably not. Okay? It might have a different n. These are not the same n. These different lines, different n's. They have different m's, they also have different n's. How do I find this n? Exactly in the same way that we found this n, by substituting the point. The same point, 3, 1, because both these lines are crossing each other on that point. So I'm going to put x equal 3. I'm going to put y equal 1. And I'm going to write 1 equal minus 3, because I had to put 3, but I've got minus now. Minus 3 plus n. And now I'll get n equal 4, which is indeed a different n. Okay? So the second line of symmetry is going to be y equal minus x. Okay? Minus x plus n. In this case, it's plus 4. Okay? Right? So some questions you'll see, they'll just ask you to sketch. Some question they ask you to also write the formula for both asymptotes and line of symmetry. In which case, do yourself a favor and just draw it all nicely together at the end of the question, not just all jumbled up and wait for me and hope that I will find it. Okay? Cheerio, guys. Bye-bye.